Okay, we're going to have a look at something called the section formula now. This is a way of coming up with a point, okay, that splits a given line in a given ratio. So if you've got this, you've got A and B, that's your given line, P is the point we want to find. We're told it splits the line AB in the ratio m to n. I've shown you the position vectors. Remember, position vector just means from the origin O to the point, okay? What it says is, if a point P divides a line AB in the ratio m to n, then, now be very careful with this, it's the other way around. Look, it's A to B, but look, the n goes with the A and the m goes with the B. I'll explain why in a minute, but basically it's that the position vector of P will be n over m plus m A plus m over m plus n B. This is because, look, the closer it is to a point, the more of that point it must have in it, yeah? So if that was 3 and that was 1, you'd need to have 3/4 of the vector B and only 1/4 of the vector A, because the more of B it has in it, yes, the closer it is to B. So that's why these are the other way round from what you might initially imagine. But if you think about it, it makes sense. But look, if it's A to B, remember that bit goes with the A on top. Yeah, and that bit, the first bit of the ratio, goes with the B on top, okay, over m plus n. Okay, we're going to use this just now then. Right, so if I'm doing this, the position vector of P will be, now we're breaking it in the ratio 2 to 1, so it's going to be 1 over 2 plus 1, with QR, isn't it? So it's Q. Plus, because remember it's the other way around, 2 over 2 plus 1 R, position vector of R, okay? Well, remember our position vectors are just effectively that written in component form because it's from the origin. So that would be 1/3 of 3, 6 minus 3. Plus 2/3 of 0, 12, 9. Okay, let's have a wee look at that. That'll give us 1, 2, minus 1, plus 0, 8, 6. Okay, add them together and we get 1, 10, 5. But if I leave it like this, I'm going to lose a mark because they've asked me to find the point. Point means coordinates. So you need to turn the position vector back into a point. So P is the point 1, 10, 5. So we make sure we write it like that. So the only catch with these questions is remembering the M goes with the second bit and the N goes with the first bit. If you remember that, you won't get these ones wrong. Okay, the second bit of today's video concerns something called the either scalar product as its proper name or dot product. This is going to be our first look at what we call the scalar, or sometimes called the dot product. We'll be coming back to it tomorrow. But basically, if we have two vectors coming out from a point, important thing, if you're looking at this, look, they're both coming out from a common point. Yeah, if they were going the other way, we would need, if it was going the other way, you'd need to look at that angle, not that one. Okay, so it's two vectors coming out from a point. Then this dot product is equal to, or scalar product is equal to, the magnitude of A times the magnitude of B times the cosine of the angle between them. But as I said, remember it's important it's the vectors coming out from a point. The other thing is, if it's a dot b plus c, then you can work it out as a dot b plus a dot c. So we'll just do a few examples using this version of the rule. As I said, we will be coming back to this tomorrow. It's probably the most important bit of higher vectors. So if I wanted u dot v, remember what we said, that is just magnitude of u, which is 4, we're told that, times the magnitude of v, which is 5, times the cosine of the angle between them, which is 30. Remember, cos 30 is root 3 over 2. So that's 20 times root 3 over 2, which is 10 root 3. So the dot product there would be 10 root 3. You're as well leaving it as an exact product, yeah, an exact one rather than a decimal equivalent. With this one, we just need to remember that that's equal to u dot u plus u dot v. Now, obviously, the angle between u and u is 0, isn't it? They're the same vector. Therefore, the angle between them is going to be 0. So that one, its magnitude is 4. So that would just be 4 times cos of 0 plus u dot v, which is what we worked out here. So let's just stick it in, 10 root 3. Yeah, we knew that already. Cos of 0, you know, is 1. Yeah, it's one of your exact values. You should know it's 1. So that gives me 16 plus 10 root 3. That'd be that one finished. What about this one? Okay, that is the same as u dot u plus u dot minus v. Remember, minus v just means it's the other direction. So if we're talking about minus v, it's going to look like that, isn't it? That would be minus v. It's still got a magnitude of 5, yeah? And that's still a magnitude of 4. But this time, we're not interested in that angle, which is 30. We want this angle, which is 150. Yes? So that's going to give me 4 times 4 times cos of 0, which I know is 16. And this one is going to be plus 4 times 5 times cos of, the angle's 150. Remember, cos of 30 is root 3 over 2. Yeah, all sine, tan, cos. Second quadrant, cos is therefore going to be negative. Okay, so it's the same as minus cos of 30. So that gives me 16 minus 10 root 3. Okay? We could have done that one, or the other way we could have done it, I suppose, is u dot u minus u dot v. Okay? Gives you the same answer, 16 minus 10 root 3, either way. So this is the first look at what we call the dot product. Important to remember, we're talking about vectors coming out from a point when we're doing the dot product. If one of them's going towards the point, remember what you want to do is this thing and have a look at the vector coming out the other side. So it's going to be 180 minus the angle they've given you. Okay, you should now be able to attempt the exercise.